right, now it's time for hyperbolas. We're ready for this conic section, and this is, if you will remember, if you've got a cone and a plane cuts it through, the top part and the bottom part, if you rotated it, you would see what looks like a parabola and a parabola if it's facing that way. I've drawn one on the board. This is a sideways one. Again, we'll be looking at curves that may be up and down or left and right. Many of these do not pass the vertical line test, but that's okay. If you look at the definition on your worksheet, it says, given two fixed points, F1 and F2, those are the foci in a plane. A hyperbola is the set of all points such that the distance from F2 subtracted from F1 is a constant. So basically the absolute value of the subtraction of those two distances. So what that means is I've drawn this hyperbola where this would be a vertex and this would be a vertex. So here are the foci. Remember, the foci are always enclosed by the graphs. That's why the focus is inside of this side and the focus is inside of that side of this graph. So the way it's defined using analytical geometry is that the distance, F1 minus F2, is equal to some constant d. Okay, so for this point, so if I took this point and I said, okay, the distance from F1 minus F2 is equal to the same constant d for that point, or for this point, or if I pick a point here, F2 minus F1 would still be d. So that's how the hyperbola is defined. It's defined with a subtraction as opposed to an ellipse, which is defined with an addition of the two foci being constant. The equation of an ellipse, which is defined with an addition property, has a plus sign in it. The equation for hyperbola, which is defined with a subtraction of these two distances, is defined with a subtraction sign in it. So that's something to keep in mind. These are the equations of a hyperbola. So the ones on your sheet look like x squared over a squared minus y squared over b squared equals to 1. That's if the center of the hyperbola is at 0, 0. Likewise, there's another one called y squared minus x squared, y squared over b squared minus x squared over a squared equals 1. Still the center is at 0, 0. What's the difference in these two? Here's the difference in these two. For hyperbola, you don't care who's biggest. For ellipses, the major axis is determined by who's biggest. For hyperbola, you're not worried about that. What you're worried about is who comes first. In fact, who's positive. So in this one, x comes first. That means the direction of the hyperbola, the way the graph will be symmetric about the x, or it's sideways in this case, okay? It's sideways in this case. It's sideways in this case too, only the center here is at HK. It's not at the origin. Over here, when the y leads, who's in front is what you ask yourself. Then it's going to be symmetric about a y, the y-axis, or a vertical line. So if the center here is at HK, even here, it's going to be this way because y is leading in both of those cases. I just want to point out that the way I'm teaching it, I really like this method of approaching conic sections. Is different from how the textbook is teaching you. It won't mess you up doing the homework, but if you are reading the textbook, the way they label their A and their B, they switch it up sometimes. I don't ever switch it up. A is always underneath the X and it always stands for a horizontal distance. B is always underneath the Y and it always stands for a vertical distance. That's different from the textbook. I just want to point that out. Okay, or it's different from other things you may look up online. So just be aware of that difference. Okay, so let's go get to this. Let's figure out how to sketch one of these. Number one, they say sketch this, and it says x squared. Number one is x squared over 9 minus y squared over 16 is equal to 1. All right. First thing, if you're just handed an equation, you're like, what in the world, what kind of shape is this? You would compare it off of all of the equations that you have learned so far. Equation of a circle, equation of an ellipse, equation of a parabola, equation of a hyperbola. Circles and ellipses have a plus sign in between. Parabola only have one variable squared. Hyperbola have a subtraction sign, and so that's how we can tell this is as a hyperbola. Okay, so once we establish what is this, I do this kind of helps me out. I'm like, okay, who's in front? X is in front. That means my parabola is going to look like that. My parabola is going to look like that. So I kind of take note of that because in the middle of all this, there's little pieces we have to put together. I don't want to forget that. Okay. Then I say, well, let's compare it to our equation, and this is the one we would compare it to. So what can we tell from this? We can tell from this that the center of this graph, the center is at the point 0, 0. Okay. What is the value of A? A is 3. What is the value of B? B is 4. From that, we can figure out the value of C. Now, for ellipses, how we figured out the value of C was it was equal to the absolute value of the bigger of A squared minus B squared, or simply bigger minus smaller here. For hyperbola, it's basically the Pythagorean Theorem. A squared plus B squared is C squared. So we'll say A squared, 9, plus B squared, 16, is C squared. So this is 25. So we get that C is equal to 5. Okay, now, as with all of our cases, C is the distance from the center to the foci. A is the horizontal distance from the center. B is the vertical distance from the center. Okay, so how do we determine where the foci, where the vertices lie? That depends on how it's oriented. So we're going to take this and start to draw our hyperbola. This is how you can do it. Take your XY axis. Sketch yourself one. From the center, everything's based off the center. Our center's at the origin, so that makes it easy. We're going to go right and left 3. 1, 2, 3. This is a point of significance. Left. 1, 2, 3. This is a point of significance. We're going to go up and down B. Up 4. 1, 2, 3, 4. 1, 2, 3, 4. And this is called the rectangular method. What you do off of these points is you form a rectangle to help you sketch your graph. Okay. Now what this helps us do is sketch the asymptotes. There are 2 asymptotes associated with hyperbola. Let me find my little, found it. My straight edge. So if you draw a diagonal through the diagonal, if you draw a line through the diagonal of this rectangle, that is one of the asymptotes of this. So I'm going to do that. This is one of my asymptotes that my curve will follow. And I'm going to draw it through the other. Okay. So far, what I've drawn is not the hyperbola, but it's going to help me form it. Now, at this point, I'm like, hey, who was leading? Which direction is it supposed to face? This is supposed to face this point. So that tells me, this is where I'm going to get to draw my curve finally. My hyperbola will follow the asymptotes. So this is one of the vertex, and this is the other vertex. And I determined that because I knew it was going to be symmetric about a horizontal line, or the x-axis in this case. This is my hyperbola. So I've sketched my graph. Now that's great. I have to label some things. One of the things I want us to label says the center, the value of A, B, C. We got to know the coordinates of the vertices, V1 and V2. Well, if I label mine V1 and V2 and yours are flip-flopped and yours is my V1 is your V2, that doesn't make any difference. As long as I can see the coordinates, that's okay. So V1 is going to be right here. I'll label this one V1 and I'll label this one V2. All right. So if this is V1, then this is the point -3, 0. I'm just going to label it over here, -3, 0. I have the center labeled. V2 is going to be 3, 0. Okay, now, how do I find the foci? Well, those are C units from the center. So C is 5. So here's the center of this. I'm going to go to the right 5 and left 5. Why did I go right and left instead of up and down? Because my hyperbola is facing this way and everything's oriented horizontally. So I'm going to go right 1, 2, 3, 4, 5 and put a point, and this is my F2. 1, 2, 3, 4, 5 and put a point, and this is my F1. So F1 and F2, I can write the coordinates there. F1 is going to be -5, 0, and F2 is going to be 5, 0. All right. There's one other thing I wanted us to label, and that is the slopes of the asymptotes. So that is pretty easy to figure out. There are two of them. One's a positive slope, sloping up. One's a negative slope. So our slopes are going to be plus or minus the change in y over the change in x is what a slope is, or the change in y is b. In general, it's b over a, right? That's going to be the slopes of the asymptotes. So in this case, the slopes of my asymptotes are plus or minus b, 4, over a, 3. Now, you don't have to memorize this. You can simply walk up to the center and rise 4 and run 3 and hit another point, or go down 4 and right 3 and get that other slope. You can just do it the kind of old-fashioned way where you're working with lines. That's the steps on the pieces of graphing a hyperbola. Let's do the second one now. If we have y squared over 25 minus x squared over 16, let's see what that one looks like. Y squared over 25 minus x squared over 16 is 1. All right. This I can tell is a hyperbola. Why? Because of that subtraction sign right there. That tells me that. Who is leading? What variable is leading? Y is leading. That tells me that my graph is going to be like this time. That's what it's going to look like, up and down. Okay. What is the origin or the center? The center of this, I don't see any numbers. That tells me it's at the origin. So the center is 0, 0. Let's see, I don't want to get that confused with the length C, so I'm going to write center. Okay, so the center of my hyperbola is at 0, 0. I know it's facing that way. What is the value of A? Oh, A is always underneath the X, the way I'm teaching it. So A is the square root of 16. A squared is 16, so A is 4. B is always underneath the Y, so B is 5. C is the Pythagorean Theorem, so A squared is 16. A squared plus B squared is C squared, so C squared is, what is that, 30, 41. C is the square root of 41. So those are my A, B, and C values. Okay, I'm going to need that. Now let's go to our X, Y and start marking things up. We know our center's at the origin, so here's my center. I'm going to go right 4 and left 4. 1, 2, 3, 4. This is an important point. 1, 2, 3, 4. This is an important point. I'm going to go up B and down B. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are our significant points. I'm going to box these in to make my rectangle. Now you will notice that my graph is not perfect. It is simply a sketch, but I'm going to label all the important pieces, so that makes it okay. Here is my asymptote. I'm going to put through the diagonal of my rectangle. And my other one. Okay, now I have to begin to draw in my actual curve. So the hyperbola will be facing up and down. Why? Because Y was leading. So up and down. So that means, so far, this is a point on my curve, and this is a point on my curve, and I want to, it will follow these asymptotes. This is what it will do. All right, so far that's what I know. So let's start labeling our vertices. This I'll call V1, this I'll call V2. All right, so this is the point 0, 5. 0, -5. Let's go ahead and do the slopes. plus or minus b over a, plus or minus 5 over 4. What are my foci? Okay. I know c is square root of 41. So that is between 6 and 7. So this is like 6 point something. So I'm going to just put it on here. This is from the center, go up 6 point something. 1, 2, 3, 4, 5, 6, 7, 6 point something. I'm going to put F1 here. This is ballpark, but I will label it very accurately here. Go down 6 point something. 1, 2, 3, 4, 5, 6 point something. F2. This is ballpark, but this will be very accurate. So let's label it accurately. The coordinates of F1 are 0. I'm going to go up square root of 41. The coordinate of F2 is 0. I'm going to go down square root of 41. So that is how you can sketch a hyperbolic curve. The next two on our sheet will not be centered at the origin. They work the same way, except for everything's built off where the center point is. So I'm going to break this into 2 videos so they're not too long.